Thank you for having me here. Last slot before lunch is always the best one. So yeah, let's see if it's not too boring. Yeah, my name is Alex. My background is more, I would say, data scientist. I worked for 5 years, working with several companies, mainly on data science projects. And during that time, I learned a little bit about the importance of data engineering, because usually when we worked with bigger companies, there was some kind of a throw over the fence mentality, right? We get a data set thrown at us, and then with the statement, do something with it. And then we're trying to figure out what to do, what is the data is about, and things like that. So this was, these were my early days, and then I started a company called Logsight, and where we are more or less doing things like that on a business level. So I was forced a little bit to adapt my thinking from engineering to business over time, but it's still, I would say I'm trying to live in both worlds a little bit, and let's see if I can show you a little bit from both worlds in this talk. Yeah, we will talk today about the automation of data cleaning, because we learned a lot during working with our customers that automating the data cleaning process is a thing that brings values to the companies. They can focus more on their core business, developing, let's say, models or approaches, methods, to automate and optimize things instead of doing the data cleaning part. And we are more or less working at the beginning as a consultant, and later on we try to implement our solutions in their environments. All right, so before we start, a little bit of motivation. So bad data quality is certainly impacting the business. So there is a study, for example, here from Gartner, that they say poor data quality is leading to poor decision making. I mean, makes sense to some extent, but it also, they calculated or did a survey with approximately 900 companies, and estimated that it costs organizations up to almost 13 million per year on average. The companies were, I would say, more bigger ones, not small companies, but I would say the outcome of the study is that bad data quality impacts your business in some case. Why this is happening? Usually, there are a few examples here. You have missed opportunities, right? If you are not able to predict market trends in a good way, or predict the outcome of certain marketing campaigns in a good way, then you will miss business opportunities, which will have an impact on your revenue. When you have services or products that are facing customers, you will end up with reputation damage or bad customer satisfaction. When you're working internally to develop models and methods in order to automate processes in your company, you would need to clean your data first, right? Which impacts your efficiency of developing these kind of things. And more data is regulated, right? By laws or by regulations based on the country that your company is residing. And therefore, you need, in some cases, to comply with certain regulations. And this is one big aspect of it is data quality. And the thing here, when we started to work on this, I always thought that this one is the most important one, right? Inaccurate inference. When you're working with AI and ML models, and you are feeding them with bad data, you will end up with bad results. But actually, business is not too interested in this aspect. It gets more and more right now, because probably of the trend of AI. But back then, this wasn't a very strong argument. And there's also a more recent study done by Monte Carlo, a data platform company, in 2023, so actually this year. And they were asking several companies and asked them here, for example, what's percentage of your company's revenue will the estimate is impacted by having poor data quality? And they compared the results from 2022 to 2023. And what's interesting here, I think, is that the number of companies that say it's impacting more than 25% is growing. So from 2022 to 2023. In my opinion, it makes sense because more and more companies right now, also small and middle-sized companies that we're working with mainly, but also public sectors are getting, how do you say, data-driven, right? So they want to make decisions based on data that they are collecting. And since this trend is progressing, so we see it, I would say that these numbers make sense because the more you rely on data, the more important data quality actually gets. So this was the business part, I would say. From the motivation, let's come to the more engineering part. This is one study that we did, for example, with one of our customers, with an innovation environment of one of our customers. And they have to implement data quality constraints on a lot of data sets. So they have approximately 5,000 tables that are somehow interconnected, and they have even more data sources where they collect data from, transform it, and then put them in these data sources. They can, the question that they asked us is, what kind of data quality criteria should we focus on first, right? And in our case, so we asked them, okay, what are you doing with the data? And they showed us actually, oh, we have a few models that we are running every week. Some of them are run every month. And we have this kind of data sources. What data quality criteria are most important? And we analyzed basically different data quality criteria. So we analyzed 6 of them and tried to see how the inference of their machine learning models is depending on these different data quality dimensions. Here in this, what you can see quickly to summarize, on the y-axis, you can see the quality of the model, so how well it works. On the x-axis, you can see the quality of the data, actually. So the more you go to the right, the worse the data quality gets in a certain dimension, in this case, feature accuracy. We tested it with different models, and we tested it on different data sets. So these are 3 data sets for classification at the top, and 3 data sets for regression at the bottom. And you can see whenever the feature accuracy data quality gets worse, also the prediction of the model gets worse as well. And we did this analysis based on the work done by Lukas Budach from the HPI in Potsdam, and they published their code actually to do this kind of analysis, and we reproduced it with the data from our customer, which was quite interesting to see, to give them recommendations of what kind of data quality criteria they need to focus first. So what we see is that data quality is important from business and from technical perspective, right? So therefore, who wants to have clean data? Yeah, almost everybody. But then the question is, who wants to clean the data? Not that many hands again, because usually this is a very time-consuming and cumbersome process. We heard one number already, right, during the introduction. So data scientists spend up to 80% of the time to clean data. Who would agree with this high number? Yeah, a few hands. Who would? So the others would disagree, right? At least I interpret it like that. Actually, I was very skeptical when first reading this number, because you see this number in a lot of material when you search in the internet. And I was asking myself, yeah, 80, I mean, it takes a lot of time, right? But 80% is a lot. And I was a little bit skeptical, so I went on a journey. When I first prepared this talk, I think half a year ago, I went on a journey to find out where this number is coming from. And I would like to show it to you here quickly. The first time, or the earliest, I would say the most linked source of this number is a blog entry from the Harvard Business School report, and they review that they claim 80% of time is spent there. They are actually referencing an IBM blog entry, which is claiming that number as well. They are actually referencing a Crowdflower survey. So I thought, wow, finally some real numbers, right? The survey, people were asked, and they're presenting actually this kind of data there, where it says that cleaning and organizing data takes 60%, but what is the 60%, right? What data scientists spend the most time on doing? When you read the text, they are actually saying 60% of the people that we asked are saying that cleaning and organizing data takes most of the time. Right? Not 80% of the time, but most of the time. And there's still 60%, not 80%. So where's the number coming from? And here also credit to Elite Dots. He wrote a blog post about exactly that, which I unfortunately found after I did this research. But if you read this report, they are actually claiming in the text, other sources are claiming that up to 80% of the time is used. So, and they reference an article from the New York Times. And after reading this article from the New York Times, I found that this was actually a citation of one single person. So one single person said, 50 to 80%. It's 50 to 80% of the time spent by data scientists to clean data. And then, you know, it's propagated. Yeah, crazy, I would say, but then we took a look and tried to find out maybe more reliable sources for this information, and I like this survey done by Anaconda, where they asked, I think, 3,000 or 3,500 data scientists of how much time actually they spent on certain tasks, and this is what they came up with, right? So data cleansing, 70%, data preparation, 22%, and these kind of numbers make more sense, at least to me, and also they are backed up by data. So instead of doing this problem statement, we are usually doing this problem statement. Data scientists spend repeatedly up to 20% of the time to clean data, right? To clean data one time, it's fine. It's a task of a data scientist. You learn a lot when cleaning data. You learn a lot about the business process of the company and so on and so forth. But when doing the same thing over and over again with very similar data, this is the point where it becomes problematic. And this is the point where I, at least as a business owner, would like to have some kind of automation to establish a process which makes sure that the data, when it comes from a certain source, is transformed in a way that it's clean at the end before my data scientists are starting to work on them. So let's start. A few errors, a few examples of data errors here. As a child, I liked this kind of grids. You remember when you have a character in each cell and then you need to search for words there. This is a very similar thing, so let's find all the data errors here. One thing is uniqueness, right? So it's a possibility that a certain column needs to be unique, but it's not. You have representation violations, where you expect, for example, here the first name, but actually the first and the second name are there. You have contradictions between here date of birth and age. You have type mismatches, where you expect a certain type and another type is entered. You have semantic errors because the column place is not very clearly defined, so therefore you can enter there whatever you want. You have ambiguous duplications, so usually identifying exact duplications in a data set is very easy, but mostly you will end up with duplications where only one or two columns are different. Here, for example, the person moved from one place from Berlin to another one, and then the zip code changed, and instead of updating the previous value, another one was added. You have typos, of course, missing values, like real missing values or default values, and you can end up with something like column shifts. So these are only, or there's one more, format mismatches. So when you have some restrictions how columns should look like, and they're actually not looking like this. So these are a few examples. There are far more, I would say, in reality, and we need to find them. This is the challenge. So how does it usually look like? We are approached by a business owner, and the business owner says, we need clean data. So what can we do about it? Let's try to implement something automated. Yeah, sure, we can do it. We have a bunch of tools there, out there already that are doing exactly that for us. right? There are rule-based approaches where you can say, okay, this column should only contain German cities that are actually existing, right? You have a better pattern-based approach where you can check whether the entry of a column is following a certain defined pattern. You can have statistical approaches where you can do anomaly detection. You can basically say, okay, are there numerical values that are far outside of the range of the norm? Yeah, that's great, right? So we have all these tools ready. There are hundreds of tools out there. Let's use them. And the next question is, of course, how do we implement them actually in our business? Yeah, it's easy, right? We just need to connect to your data sources, and we need to configure these algorithms properly. It's simple. Look here, right? We need to write a little bit of code, which is fine, right? It's our task to do. We can do this. But then we have also a few constraints and configurations that we need to do in order to configure all these algorithms. And this is the point where business owners starts to ask themselves, was it really a good idea to have clean data? Because although they understand that this part on the left-hand side, the code is done by us, right? But the constraints and the configurations need to be done together with them, because we are not understanding the business processes of them, so we need to do it together with them, which takes a lot of time from them, also from us. And then what you can sometimes hear is something like, can you clean the data without us telling you the rules and parameters? Maybe something with AI. Yeah, let's do it. So, all right, we start to think, and then we say, yeah, can you at least show us a few examples? And then we probably can end up with a configuration that might work. Yeah. So basically, the concept that we are employing here is also based on two publications that I want to mention here. And the concept is that the user cleans a few significant examples of the data set. We parameterize the data cleansing tools to do the rest. So this is the basic idea. But there's one challenge, because when you take a look at real data sets from the industry, it's usually not the case that there's only one problem there, but data sets are a mix of different data errors and data problems. And each of them can be solved with a specific set of algorithms or methods, right? So only a combination of these techniques can yield a high coverage in detecting data quality problems in the data set. And here, basically, just an example, in this chart, the numbers, or you can see all the different methods around, right? And the numbers are the amount of errors that can be detected in these data sets by this certain method. And there are always a few errors on the outside here that can only be detected by one certain method and no other methods, which makes it a little bit difficult for us, because the search space for us becomes the number of algorithms times the amount of configurations that we can use for these methods in order to find all the data problems in the data set. So the challenge here is actually to find an optimal configuration setup for all the data quality tools that we are using. And for that, we developed, we basically took an approach which was published by Mohamed Madivi. I cited this publication previously. They published it, or they wrote a great paper about it. They also published the code, and we more or less built up on their solution to automate this process. And I would like to quickly explain to you how it works. So first of all, we define, or we take one column, which is here the zip code column, and we define a certain set of rules, a lot of them. And whenever the rule is valid, if you can answer yes to this question, we put a 1 there. If you can answer no to this, or if you need to answer no to this question, we put a 0 there. And we end up with something like that, right? S1 is the value is longer than 5 characters, and you put a 1 wherever this applies, and 0 where it's not. And you do it for all the rules, right? In this example, we are using a binary encoding, but in our methods, we are using also distance-based approaches, so there could be also floating point numbers there. So the vector size becomes the number of algorithms, of course, that we are using, times the configuration. So we have the same vector size for each column. The next thing that we'll do is we cluster these encoding vectors. So we are building something like that. So vectors that are very similar, right, or even the same, are ending up in the same cluster. This is the basic idea. And then when doing this, you can see it here, right? Here we have actually 3 clusters in this example. We're asking the user to annotate or to review one example of each of these clusters and say whether this is clean or not, if it's an error or not, yeah, right, for each of the columns. And here you can see the results, right? The first one, this one is good, and the rest is errors. And we are assuming that entries ending up in the same cluster have a very high probability to have the same classification. So in this cluster, they're all good. And whenever there's an error, all of the entries in this cluster are bad. We analyzed this on a data set, which here, for example, it was two database tables that we analyzed here. And we analyzed how many examples do the user need to classify or to mark, to analyze, until we reach a good coverage. And the outcome of it was, in our case here, that the user needs to clean 50 examples until we can find a configuration that yields a high coverage score. All right, now we know how to find the errors, so how can we clean them automatically, right? But I would say let's keep this topic for another talk or for later discussions, and let's come to the summary. So clean data is important for the business and AI and ML projects. Parameterizing this data cleansing tools is very difficult, expensive, and time-consuming. And one example-based approach reduces the workload for the customers to implement data cleansing processes in their companies. So, thanks a lot.
Thanks a lot, Alex.